Mersenne primes are a fascinating category of prime numbers, defined by the formula 2 to the power n-1. The number 2 to the power 31-1 is a Mersenne prime, named after the mathematician Marin Mersenne. A Mersenne prime is a prime number that is one less than a power of 2. Specifically, it takes the form mn equals 2 to the power n-1 for some integer n. These primes are named after Marin Mersenne, who studied them in the early 17th century. Mersenne numbers have intriguing properties. For instance, if n is a composite number, then 2 to the power n-1 can be expressed as a product of smaller numbers. Look, the left-hand side is a geometric progression with a common ratio 2 to the power of a and the number of terms is b. Thus, if n is a composite number, product of n b, then m of n can be written as a product of two proper divisors and hence not a prime number. Look at the calculation for the Mersenne number for n equals 10. An equivalent definition of Mersenne primes is that they are the prime numbers of the form mp equals 2 to the power p-1 for some prime. Page check m3, m5, and m7 are prime. However, not all numbers of this form are prime, as demonstrated by m11, which is not prime. The largest known prime as of October 2024 is the following. To check whether a Mersenne number is prime, one approach is to search for possible divisors. A useful property of Mersenne numbers simplifies this search. If q is a prime divisor of mp, then q is congruent to 1 modulo 2p. For example, consider m11 equal to 2 to the power 11-1, which is equal to 2047. If it has a divisor, it must be of the form 22k plus 1. Checking primes of this form, we find that 23 divides 2047. Therefore, m11 is not prime. The Lucas-Lemmer test is a standard primality test for Mersenne numbers, applicable only to numbers of the form 2 to the power p-1. It involves a specific algorithm that determines the primality of these numbers. Start with s note equal to 4. Compute the following congruent. After p2 steps s, p2 is divisible mp, then mp is prime, otherwise it is composite. Let's examine the calculation for m11 equals 2 to the power 11-1 equals 2047 using the Lucas-Lemmer test. Through a series of steps, we find that m11 is not a prime number, demonstrating the effectiveness of this test. The number of iterations required to check whether mp is prime is p2. For example, for p equals 5, we need 3 iterations, and for p equals 11, we need 9 iterations. For the largest known prime, p equals 136,279,841, a staggering 136,279,839 iterations are needed. GIMPS, the great internet Mersenne prime search, uses heavy computational power to discover new Mersenne primes. Since 1996, GIMPS has found every largest known prime number, with the current record being 2 to the power 136,279,841-1, which has over 41 million digits. Electronic Frontier Foundation, F, will award prizes $150,000 for the first prime with at least 100 million digits. Try, if you can do this.